let's start this second session about Redux Saga. Well, let me introduce myself. I did a presentation in January, I think, about Redux here in this meetup. But well, I'm Nacho Martin. I work at Limenius, and we work to build tailor-made projects for other companies or for final customers. And yeah, we have been using React for 2 years now, and React Native less, but we have some applications in the market as well. So we are really happy with React and the ecosystem. And well, let's see. What we're going to talk about. We are going to talk about first, for those of you that are new to the React ecosystem, it's important to know that sagas are not indispensable. I mean, you can do lots of projects without sagas. I mean, it's not something like, oh, I saw this presentation of Redux sagas, and it's something I really need to apply from the first day. It's absolutely not. So we will talk about this when they are needed, in which case, for which scenarios are possibly a solution. We'll talk about the theoretical background a bit, because in the Redux Saga's website, there are some links, for instance, that I think, for instance, that are misleading, and so we'll talk about a bit in detail about this. Also, I want to ask how many of you are familiar with generators of JavaScript generators in ES6, okay? But still, we'll do some introductions to generators, because sagas are about writing generators all the time, so we need to know this syntax. And the specific case of using generators for async code, which is what we are doing in sagas all the time. And then we talk about sagas and examples of it. These two topics, generators and sagas, at least to me, took quite a long time to understand them. So I don't think it's realistic to hope that I can explain. I would like to explain in an hour everything. And so, but I will be happy if instead of understanding every line of code and everything, you have like this kind of general idea of what are they for, which patterns will they solve. So if you run into problems that sound familiar to you, you can maybe say, okay, I remember this presentation, I can check out sagas, this particular thing, I think I can do it with generators or sagas. Okay, let's start. First, as I said, maybe you don't need Redux Saga. In which part is Redux Saga, which problem is attacking React Saga or solving? If you remember, if you're some kind of familiar with Redux works like this. So you have a view, and the view dispatches actions, and the actions are used by reducers. So they produce a new version of the state based on this action, like user has pressed a button, so I can produce a new version of the state based on this action and the previous state I had. And then there is the concept of middlewares in Redux that is used, can use for several things, but the primary use is to do this kind of side effects, to communicate with real world, the outside world. So we will be, in this talk, we're talking about this rectangle. Okay, so we'll call this side effects, communication with the real world, changing the state of the real world, extracting information from the real world, and this produces actions that also the reducer can apply to the state. So imagine, for instance, the typical case for this kind of side effects is to do a request to an API backend. So without any middleware, the only thing we can do is say, okay, I want to do a request, and then the reducer receives this action and says, okay, produce a new state. That means the user wants to do a request, but it's not doing the request itself. It's just doing this. You can only do this. So for doing an actual request, you will need to use a middleware. So the middleware receives this action too, and does something, communicates with the outside world, and probably, it's not required, but probably it dispatches a new action. Okay, it's a success, and the data is here. So the reducer gets this data and puts it into the store, okay, or modifies this, not modifies, but produces a new version of the state. Also, in the case of errors, there are branches and so on. I mean, this can be as complex as your project requires. It's not only success and error, but can be a lot of stuff here. So if you only want to do this kind of API request of fetching data and success and error, well, sorry, yeah. Well, in fact, what we are talking about every time is middlewares will take care of side effects and it will isolate from your pure code that is not touching the real world. It's only logic. Okay? Then, if we want only to do this kind of requests, API requests, this is Redux Saga. Okay, this is another middleware that is not Sagas, that is Redux Saga, and works like this. Instead of returning objects, that normally your actions are objects, it can return a function that accepts a parameter that is dispatch, and it dispatches new actions when this async request is resolved. So say, okay, this is the error, or this is the data you want. Okay, if you only want to do this, it's perfectly okay to use Redux Saga. Okay, because this library also has a very nice thing that is only 14 lines of code. So I think it's important it's very nice if you have a library that you can read, like you can understand the code fully. I mean, if you don't need more, it's better. But what if you need something else? Maybe you need, for instance, kind of typical example would be a WebSocket connection that you connect, and then it can start to send you actions, like asynchronously all the time. How can you do this with Thang? I mean, it will be quite difficult, or you end up maybe writing your own library for doing this kind of stuff to orchestration. Then in this case, you have several options, and one of them is Sagas. Another one is observables. There are more. It's difficult to compare them because, for instance, in my case, I invested a lot of time working with Sagas, and you need a complex problem for this. I mean, you cannot try them in 1 hour. You need like, okay, I have this problem. It's a pain. I have to learn how to do this, and I have to model my problem so in the specific way of Sagas. And then, for instance, now I'm happy enough. I think they are good enough, and if I get a new project, I will probably use Sagas again. I mean, it's difficult for someone to say, okay, I've not found anyone from Sagas or observables that says I'm not happy with my current solution, so I'm happy enough, so I want to invest the time to learn the other library. So I talk with people, and they are like, the worst case scenario is that you end up with a library that is good enough, which is I think is quite good. Also, I don't think this is a problem that we have the final solution. Maybe there will be something else in the future, or maybe with the new features of JavaScript, it will be better or easier. But still, I think both of them could be good options for what I know. Then, about the theoretical background of Sagas. Because there is something, if you want to learn Sagas and you are following links and you want to look for videos in YouTube or tutorials, there are some meanings of this word. I mean, this word has different meanings. Okay, it's interesting how this word attracts this kind of misinterpretations. Like, for instance, in the real world, Sagas, it was used originally it's the tales of Icelandic kings in the 12th century, that they went to the sea, and then they met other people, and then they killed them all, or plundered their villages. But 8 centuries later, we use the word like this. My neighbor told me the saga of his divorce again. So, okay. Has some resemblance, yeah. Similar, but not similar. It's not the same. I mean, it was very specific, and now it's not. It's something completely different. And in computer science happens the same. I was reading, like, in Redux Saga, they have a link to a paper. Like, say, if you want to know more about the basics of this, the fundamentals, there is a paper here in the Redux Saga page. And then I saw the paper and saw the guy and Googled the guy. And in fact, I saw that he was advisor of Sergey Brin, one of the founders of Google. So I said, okay, I'm now learning from the same source of knowledge as Sergey Brin. I'm in the right path. Then I read the paper, and I felt very stupid because it had nothing to do with Redux Saga. Had very specific meaning, like multiple workflows, each providing conversation actions that, I mean, took me some time to say it has nothing to do with Redux Saga at all. But as it's a scientific paper, I mean, it's not obvious at the first time you are. Okay, this is notation, I don't. Okay. Then, like, it's not 8 centuries, but in computer science, the time goes faster. Nowadays, you can use sagas as a word to say, well, the paper was in the 80s, so nowadays you see this use as well. A process manager used to orchestrate complex operations, and in Redux Saga, a library to manage side effects. So this is important because it can be, I saw people asking questions about sagas saying, oh, I followed this video, but I don't know how to do this with Redux Saga. Well, the video was about the original paper, so it's important to know that there is another meaning for this. And then, let's go to the thing. Sagas, when we are writing sagas, we are writing all the time generators, which is a new feature of ES6. Whenever you see this function asterisk, I mean, at the beginning it was like, it's a function, or what's, I mean, so you see this asterisk, it's a generator. So it's important to know how they work at least a bit. You don't need to know everything, every detail for working with sagas, but it doesn't hurt. So let's write a first generator. Okay? Generators are this kind of functions that describe sequences. So they are yielding sequences. Okay? So when you create a generator, when you make an instance of a generator, you get an iterator. Okay? And when you make this iterator and if you want to debug it, okay, you debug it, this, you don't get a result. You don't get 1, 2, 3, or you don't get undefined. You only get an iterator. So it's an object with some properties like next, we will be calling later. It doesn't behave like a function. Then we work with these iterators by calling it the method next. What does next do? So next thing that next do is to travel, makes the generator run until, in this case, the first yield. So the next yield. And yield this value. I can return this value. So we can extract values from the generator. In this case, if we debug this, we'll say value 1 and done is false. It's not only the value, but it says, okay, there are more values to be extracted. You can continue extracting values. I'm not finished. Then if you call it next, I mean, now the code is waiting here in this yield 1. It's stopped. Okay, it's not running at all. Then if we call next again, it will run until the next yield. Okay, it will run until here, and this value, this 2 that is yielded, is the value that we can extract. The value that we can see in the console. So 2 and done false. Similarly, we can do it 3 times. Code travels here, and then we check the value yielded. And we can call it again, and the result will be different. Will be, okay, I'm finished, so the value is undefined. There is no, if there will be a return value, like in a function, we will see the value, and it's done. I mean, you don't need to call me again, like, it's over. This sequence is over. So, we can extract data iteratively from the generator, but another thing we can do is to have a very directional communication. We can also put data into the generator as it's running. So let's see an example of this. Okay, in this case, to accumulate values. So this is important because there is a sequence of things that happens in generators. If we call the first next, this parameter that we pass will substitute the yield that is waiting. This is important. So at the beginning, there is no yield waiting, so this parameter goes to the heap of data. It's lost. We don't need to even to write it. It just goes to a better place. And then when we call, but then the next, what happens next is that as we are calling next, it goes to the first yield and stops there, and yields this value first 0 and done false. It's first 0. So we do it sometimes more. Now this 1 will substitute this yield statement. So x will be 0 plus 1, and we can debug this. Well, first it travels. I mean, the sequence is this. We pass the parameter, travels, extract. If we think in a different way, the code never does what we want to do. For me, it was very frustrating to what is the exact sequence of this. So travels to this place, and then it's yielded. So console value second is 1. Then we can do it again. So pass a parameter, we'll substitute this yield, and x will be 21. So the code will run, the generator will run and stop here, and we'll get 21. And finally, same thing, substitute here, code travels, it's running until here, waits in this yield, and returns the value of the yield. Fourth is 321. And that's it. I mean, we could do more, but then it would say value undefined, and I'm done, it's true, it's done, stop it. So typically you don't write generators this way, just writing the values manually because it would be stupid, but you normally do it in a loop to kind of have infinite sequences. For instance, a Fibonacci generator or so on, but it's much more difficult to explain this because a similar code will be this, but I cannot explain like, then the code is waiting in this yield because there's only one yield. It will be messy to explain that, but this is what you normally do. So you have kind of these loops. It's perfectly normal to have while true in a generator because we are controlling how many times it's running. So it's not like consuming CPU running continuously because we are making it stop, but we are controlling the code from this side, this right side, we call it like a runner, generator and a runner. And the same, 0, 1, 21, 321. Then, one thing that is cool from this, I think, once you have this kind of generators of sequences, you can also use them as if they were native iterators, native iterables. So you can have an object and say, my object has this generator as iterator. So you can use these native operations, like you can have here again numbers of p, a generator. So you use them as if it was native iterable. But and this is like the normal examples of generators. But the important thing for us today is to see how they combine to do async code, which is the cool thing for doing side effects. So a bit more complex code. This code is not so important to understand it totally, but it's important to explain it at least once. When we combine promises with generators, what we will end up doing is the goal we are looking for, the thing that we want, is to make this code as easier to understand as possible, the generator code. And the other code, if it's more, this code in runner code, on the right side, if it's more complex, we don't care so much. We will see why. So in this case, we have a promise that simulates a server request. It's just a timeout and gives us an object, the username and hash. And then we have this generator and a runner. So if we call give me the first value, next, and give me the first value, it will return this promise. So it will return this promise and say the promise is pending because it's waiting, has 4 seconds to wait. So it's pending. But we can say, okay, when the promise is resolved, yes, we call next, and we inject this value back into the generator. Okay, so well, we have this result, and then we inject into the generator, it substitutes the first yield, and we can get it back. So this code basically works as if it was sync. We don't care so much about callbacks and so on. For this example, it's pretty stupid code, but if you want to do something like this, for instance, fetch user, do something else, we can just have sequences of sync statements without caring so much about if they are async or not. I mean, so here goes, we're doing async as if it was sync. It's easier to understand. And it's the code that depends on our projects. Okay, it's the code that is our logic of our project. Fetch posts, whatever. And then we need a runner, right? The runner in this case will be more complex. The nice thing is that we can do it in a loop and we can reuse it between projects. So in fact, we don't really need to write this generator, this runner, if we want, because we can use some libraries that are there for us. So we can, if we are using this kind of libraries, we can just focus in writing our code here as if it was sync, kind of knowing what is going on, but it's easier to read that callbacks and so on. So one library for this is Redux Saga, that does more things to control the flux of operations and orchestrate, but there are other libs that do things differently with this idea. Then, Sagas itself, because now, yes, we will focus now on this part, of writing this part. the generators, and we can forget about the details of what is how this library works. So, well, first the setup. I mean, when we do the Redux setup, we create the store and we apply a middleware. This is Saga middleware. This is typical for several middlewares, also with thanks and so on. And we have to say middleware run this Saga, and we provide a root Saga. We will see later that Sagas can have children or can fork it themselves, but we have to provide a first Saga that will be run. Then let's do this example. First side effect. I was thinking about a side effect that is simpler enough, so we can show only one piece of the Sagas at the beginning. So imagine that we just want to play a sound. I mean, I will be presenting some examples about, for instance, a chess game. I think games are good for this kind of examples because they have a lot of side effects and they are still easy to understand, that easier than we have products and then we have a user that can, with games I think they are good examples. Or maybe we want to play a sound when the user moves a piece, makes a movement. When I say this click in chess games. So let's suppose we have this kind of sound manager object that has that can load sounds and MP3s and so on, and can play them. It has this method for playing the sound. Yes. We give them a name like movement, and then it plays the sound. So how could we use this in React? Because this is a side effect. How can we combine this? So even this sound manager that has nothing to do with the state, or it's difficult to combine with React. Let's say, for instance, we say, okay, on press, we just play the sound using the sound manager and the name of the sound. But we have this problem. Where does sound manager come from? I mean, how can we access this from the view? It's not trivial. It's not obvious. Okay, then maybe we just dispatch an action and Redux will play the sound. But Redux doesn't know anything about our sound manager, so it doesn't have access to it either. So we can do this directly without any middleware. So we can think, okay, then maybe we have access to it because we pass it from its parent and the parent of its parent and the parent of its parent, and then every component in the application has something to do with a sound, like sound manager, and why this navigation toolbar has something to do with sounds. You don't know, yes, trust me, it works. And then, yeah, it's a fireball. So, or we can say, okay, we put it in Redux, and then we connect the components to this state because it's in the state of the application. But it's not nice to have logic, like functions and so on, in Redux, because it's not serializable and it breaks some assumptions in Redux. So you cannot type travel, you cannot persist, maybe you use another library and it will be broken. But still you can say, okay, but it works, I made my deadline, it's okay for me. But then you're happy, but you have this sense of Spider-Man that something will happen. And then they say, okay, what if we want to play a sound when the other opponent also moves? And this comes from a WebSocket connection. This comes from an event in a WebSocket. Then we try to apply the same solution, and at the end they say, okay, when the component mounts, we connect the socket and we pass the sound manager here, which is like, why? What has to do connect socket with the sound manager? And we feel like, yeah, when you have 6 dependencies like this, it's like connect socket, sound manager, some other stuff. What's going on here? It's totally crazy. So it's just because we don't know anything better. So here, this is a good example, for instance, for Sagas. Because you can write a generator. In this case, in Sagas, we have some effects, and we can just do these effects. The first effect we are going to see is take. Take will observe, we will stop until it receives an action called constant play sound request. When this action is dispatched, then the generator will continue its execution. And then we can debug the sound that this was received, this is okay. And also we can actually play the sound. I mean, if we pass the sound to the sound manager, this case is okay because we are saying, okay, Sagas are about side effects, so they can receive everything related to side effects. So it's they kind of mix together. So now we can say, okay, take this action and play the sound. This is good, this works. It can be done better because the problem is that we need a mock to test it. And the people reading Sagas have been thinking about a lot of how to test things easily because this is a pain to test. So in fact, we can use call that will do a call for us But when we are testing this generator, if we test it, it will yield it will yield a function that declares, it's declarative. It will declare what the runner will do, what Sagas will do. So when we are testing, we can just check that this value is yielded. So we can just compare, okay, the object I received from the call is the same object I wanted. So it's easier to test. So it's important not to do calls directly, but to write call, which is just, it's simple. Then we have take and call. Also call, by the way, is blocking. Will block until the sound is played. In this case, it will return automatically, but if you are doing a request, it will block until it's resolved. So it's important to have this in mind. It's a blocking call. Okay. Then, now with this, we had this, but the problem we have is we are only playing once a sound because the generator will go to the first yield, second yield, and then we say, okay, I'm done. You cannot play more sounds. So we'll terminate. So we can just do, as we saw, while true, and then it will run continuously. And this is very common to do, very common pattern to do. So there is a shortcut for this. It is slightly different. We'll see later the exact equivalence, but we can also take every action. Yeah, we can also use take every. So we can observe every time, and it's nicer. It's a helper. So yeah, you can say, okay, react to this action, and then I call play sound with this parameter, and then we will call play sound with this parameter and the action that has been observing because it's integrated totally with Redux. Then now we have call, take every, and we can also put actions, dispatch actions. So we receive an action, do something, and then we dispatch the action back to Redux or whatever other Saga that is listening to it, so we can kind of do more complex stuff. So we receive this action, and then we dispatch this other. And with this, dispatch this action. With this, we have everything we need to write AJAX calls, API calls. So you remember we had this in Thank, okay? And then we can write the same thing. This has some callbacks and so on. We can write the same thing in Sagas, which is a bit longer because for this particular example, as I said, maybe if you only need this, it's easier to just use thanks. But if we need more and you are nesting callbacks and so on, it's much better to use, I think, Sagas or other similar solution. In this case, with Sagas, we have the root Saga here, and we say take every request of sandwiches, and then you call this call that this promise, fetch, and then you will receive either the success or an error, and this has no callbacks. So we can do more complex stuff, and nest and so on, and then I do something else and so on. Then.
Can you go back for a second?
Yeah.
In the last line,
yeah.
you don't have this method.
This
shouldn't be that sandwich request.
Sorry, this one?
Yes, the make a sandwich.
Yeah, this is from the view. This is totally separated, but if we can call this method from the view, say dispatch this action.
Yes.
This case we can do also the same, but this is in the view. It's a separate file. It's just the.
But from the view, you are calling sandwich request now, or not?
So well, okay, because I have an action creator. Okay, it will be the same as dispatch. This thing, like type constant sandwich request. Okay, sorry. Yeah. In this case, it's the same. Yeah. Because no. Okay. No, this is normally we have this will substitute it. It's a simple function, an action creator that will return this object. So it's you can also write this object here, and it will be the same. It's just that I use action creators, and I was copying the example, and I saw that it worked, and yeah, but it will be like this. So that's good. Yeah, we are reading the code. Thank you. Sorry?
It's dispatching an action.
Okay.
Which has a type of sandwich request. That's it. So make sandwich.
But you want to trigger the sandwich request method in the dispatch or not?
So dispatch takes an action.
Yes.
Right? And that action has a type.
Yes.
And that type is sandwich request, which is picked up on const action down below. Actually, that's your put.
Ah, sorry, yeah.
It's the take every.
Okay, yeah, this one. Sorry.
Yeah.
That's
So
right.
that
Yeah.
one, that is a string which matches the type of the action which is dispatched down below.
Okay.
Right? And then every time your UI dispatches that action with that type,
Yeah,
then the sandwich request function on the right is invoked.
I can do this. It's easier.
Sandwich.
Right? That's it?
Okay, now I get it.
And then because this is middleware, Saga
Mhm.
has access to
Okay,
all of
it will kick in.
and the take every will.
Kick in. Yeah.
So,
Sorry.
I will, no, sorry. Thank you. Yeah, so we will dispatch it from the view and with an action creator of like this. And take every will observe this particular action and then, call this sandwich request function. And then we put that we are doing, in fact, we should do sandwich request requesting or something like that. Yeah, I copied this example from the thanks example. I got it. Well, anyway. Yeah. Anyways, it's like this. I mean, you do something like I'm receiving this, I'm starting this request, and then I have success or error. But yeah, looks like this. So because the actions now I receive by the reducers and also by every middleware.
Mm-hmm.
So Sagas can also like listen, like kind of. Sagas knows, okay, I have this action. I know I have a generator waiting for this, so I can just do it, and then it continues working, and then calls another generator, and so on. Okay, thank you.
One question.
Yeah.
So it's a bit more general, but what I always wonder when seeing a complex code like this, so you're mixing middlewares.
Yeah.
Is there a way to ensure that the Redux action type is unique between libraries? Because it sounds like something like a global that could conflict, and if you're using two libraries that use the same action types.
Well, you can use some kind of namespaces or something like that if you want, like prefix. But I don't think you can. Or I don't know. Maybe
What we do actually is we have all of our sagas bundled together into one folder, and this saga folder actually has its own actions file. So all actions which are picked up by the saga system are mutually exclusive with our store.
Okay.
Because we actually don't want any actions which are handled by Saga directly being handled in the store. That's just not really what you do. So you just have your view import action types from a certain location.
So you mean that you have these constants separated, so the ones that Saga uses from the other ones?
Exactly.
So you import either these constants or constant Sagas, for instance,
Yes.
or something differently.
Yes.
So you have different kind of.
So we have
sets.
like app sagas, if you will, app sagas actions,
Okay, and then
app store actions, for example.
makes sense. Also because I feel like some actions are commands and others are
Yes.
has this problem.
Yes.
I didn't want to talk about this, but now that it's coming, some of them are commands like play a sound,
Yeah.
and some of them are intended to be in the store, but
Yes.
this for CQRS and things like that is different. But anyways, well, but there is another effect that I have not used, but because I don't have this particular requirement, but it's nice to know, is take latest. So take latest will launch this task fetch data for every action, but it will, if the other tasks are running, only the last one will be in effect. The other ones will be cancelled. For instance, I was thinking about, for instance, if you have a kind of auto-completion mechanism, and the user is typing very fast, but your server is reacting in different times, maybe you don't get the responses in order. So you can just take the latest one and cancel the other ones. Still, the request will be launched, but not the effects. I mean, you cancel the promise. Then, this is one thing. If you have this particular requirement, could be useful. Then, another important one is fork. Imagine, for instance, in our game, we want when the user joins a game, okay, we watch for the action join game, and then we don't want to write all the Saga for the game. I mean, we have like a separate set of stuff that can happen. The user moves, we receive another movement, the game can end, so we just define another saga that observes these other actions, for instance, in this case, observes into us things that happen listen to a socket or things like that, and we can just fork it and have a children saga. This is also interesting because you can have like separation of sub parts of your application or sub parts of your side effects, and so it creates a new task without blocking the cover. So when we go from this fork, it will just continue running the next one and the next one and the next one. It won't wait for the first one to stop, as it will happen with call. Then this opens the door for canceling sagas. In this case, for instance, if we want the user wants to, maybe he leaves the game. Okay? Some users in chess games, for instance, they are assholes, and if they feel that they are losing, they just leave the game, and the other player is like, what's going on? But if we don't program our application correctly, the user will still receive the actions that are dealing with the game, although he is maybe in another game, so he will start receiving movements from different games. We don't want that. We want to cancel the saga that was going on with the game itself. So we can take the constant join game, we start the game, and then we take this game saga, and we can start a new saga saying, watch this an action called leave game. Then this action leave game, we can also take while, but in this case, for instance, if we find the action, we receive the action game leave, then we cancel the other saga. So we cancel everything else. I need children and everything else, terminating. So in the game saga, we can do whatever here. I mean, join the channel or whatever. I mean, listening to events, whatever. But if the saga gets canceled, it will go to this finally, and we can know if it has been canceled or if it has happened. We can know. We can, for instance, close the connection. Maybe we could close it anyways. But this is an example of. I mean, we can know if it has been canceled or if it has found an error, particular error. So we can also do this kind of forking and cancellation of trees and cancel. Communicates with this cancel that these are requests have been cancelled. Then there is another option. It's called spawn. The difference is that in fork a task waits for its forks to terminate, and errors are bubble up. If some children finds an error, everything crashes. Like it's okay, maybe for you, depending on the use. And also, if you cancel a task, you cancel all its forks, as we saw in the game. And in spawn, you create a new task that is detached, is kind of sibling of the root saga. So errors also don't bubble up. If spawned saga finds an error, the parent doesn't notice, but we have to cancel them manually. So depending on the use, can be one or the other. Then, we have now fork, so we can really implement we're using take and fork. I mean, some of the effects are kind of combinations of the others, so it's more complex, but it's just forking. So it's similar as what we did before, but it's just something in the documentation. So you see that you can build other complex constructions from smaller building blocks. Okay, right. Then we have stuff for running stuff in parallel, like for instance all. We say all, then it will launch all these sagas in parallel and will log until all terminate, as if it was just calling one single saga. And then we can also have race. Race, it's a more particular, not so used, but you can have different tasks, and when the first one terminates, the siblings will be cancelled. So, for instance, in a chess game, we can have artificial intelligence that is calculating new movements. So, and these kind of programs normally, they know the best movement found so far. Okay, so, and maybe you can give the user a button that says, okay, if you press this button, you force the computer to play as soon as possible. So right now, with the best movement you have found so far. So we can have two tasks, and cancel will just observe this force move and cancel the. So it will finish first and cancel the first one. Then this is a pattern that is very typical. Watch for an action and fork and start a new saga. We will use this now. So this is very, very typical. So take a request and fork it. It's similar also to take every. Then with this, there is a variation of this pattern. This will just take every action and fork and fork and fork. If you're receiving like 100 actions per minute, it will just launch 100 tasks. But you can also do it, for instance, things sequentially using an action channel. An action channel, it's kind of a buffer, okay, that will buffer this action, in this case, request. So we can take from this action channel, this request channel, we wait until there's something in there, and then we can call blocking a request. So it will only one of these 100 requests will run at the same time because it's blocking. But then when it's finished, it will go into the next iteration and we'll check if there is something in the action channel and do another request. So you can do kind of things sequentially, so you can orchestrate things differently depending on your needs by playing with the effects. Okay, then these channels things has a nice thing, a nice sibling, let's say, which is the event channel. We can create a channel that is not listening from Redux, but we can kind of, for instance, we have a WebSocket and we know that this WebSocket will be kind of emit events. So we can create a channel that the WebSocket will be used to emit this kind of actions. So we create an event channel, which is a function with a parameter emitter, and we can call this emitter to emit kind of actions. So we can emit our own actions that are not started by Redux, not started by any view, not started by any other saga, just from the WebSockets. And we can use now these WebSocket sagas as if it was another source of events. Okay, we can just call it and take and so on. If you want to know more, this post was very nice for doing this particular thing and has real world examples. And then this is something, finally, well, select is something that you can use for checking the state of the Redux store. That is something you shouldn't do very often. Also depends on the other middlewares behaving correctly, but maybe for some cases it's useful. You after the users have applied the action, you can check what's the state of the store. So it's better not to use this, but if you need it, you can still do it. And finally, something lighter. There is a helper that I like, this delay thing, which allows you, for instance, to sequence this. I mean, you can, for instance, when you end your game, for instance, you want to show first the end game, the game is over, and then show the winner, and then update the scores, and then 1 second later, play again. So these kind of things you can, I mean, there are several functions, several helpers, in this case this is only a helper, that allow you to sequence things and orchestrate your side effects. So and with this, I think we saw quite a lot of effects and so on. So we saw take every, take last, for taking actions, for listening to actions. We saw call to block by calling a task, starting a task. We saw put to dispatch a new action. We saw fork and spawn to kind of have children's forking. We can cancel them. We have channels and event channels to buffer incoming messages. We saw all and raise to start things in parallel. Select to check the state, and yeah, just the delay thing that is helper. And thank you if you have questions or. Yeah.
How would you debounce event?
Debounce. Well, I don't have internet now, but there is an exact, like in the Saga's documentation, there is a code for debounce. So I will just copy the debounce. And throttle, there is a throttle and debounce.
Okay.
So both of them are in there, like common patterns.
Okay.
So I didn't use it, but I know it is in there. So yeah, it's based on, I don't know exactly which components because I never use it, but yeah, maybe take last or some combination. Okay, I don't know. Something else. Okay, then.